Yep, so in the previous episode we started putting this thing together, and it's reasonably close to completion. We're looking at doing a project plan for that, but I'll do that later. I don't really feel like doing that just at the moment because it's a pretty boring thing to do. But putting that together is a bit of fun. Then underneath it we've got this swivel base to put together. That's inside this box down the bottom, underneath that brown thing. That box is empty, yeah. That one there. Now, here we were looking at delivering courses in engineering, science and maths. Probably start with technology because that's what I know, but I'm a hobbyist, I'm an enthusiast in creating ways of automating tasks that people don't want to do. Right, so this device here would be used to measure force and resistance, that stretching cable there. So we'll know that in order to get that thing to this square here, yeah, that lines up, right, in line with my toe there, takes a certain amount of force, right? And that force might even be weight. So we might have a 2 kilo weight, and I think that'll touch the ground if I drop it, but no. So how much weight, if you suspended it vertically, how much weight does it take to stretch that thing from its initial state to say 1 metre? And it might be 3 kilograms per metre on that particular rope. So if you had 10 of those ropes, okay, now you're a bungee, say you're a bungee strap provider for tourists where they jump off, bungee, right? You've got to calculate based on the weight of the person and the elasticity of this thing, so how much resistance this thing's got. And I think that has been already determined, and I think instructions are on the box, possibly. But this is the very light version, and it's got, yeah, there you go, it's got the weight equivalent, the resistance. Yeah, I thought it did. Genius. Available on its website. So that's something anyway, that's a start. Can we see that? I can't read it with these goggles. Good, but there you are. So there's more information available there. So there's the ultralight version, the pink version. Then if you double it, what happens? And so on. So basically, those calculations we're going to use for calculation of force and torque and so on. So if we could coil up the kinetic energy in some of these bands, can we make something of a veritable spring? What other applications do they have? And I've got a bunch, right, where if you're able to replace the a motor, you have one motor, you wind those on to the setting you want, and then when you hit the button they just go woof and give you a burst of energy, and that might kick over the compressor on your air conditioner, because you can add the energy to that coiling effect in small increments and build and build and build and build, I think. Or not. Maybe not. So, does it need as much kinetic force to insert the energy? Well, you can use gearing. Anyway, you can basically produce a burst of energy using those bungee straps. Now, Why? Well, say I'm on this thing here, sitting down, right, and I've got an overhead strap like that one I'm hanging on, right, it's just hanging down from the fan, right, and it can go to any corner of the room by one of the suspension things, right. You're what? Yeah, like one of these doohickeys here. I've tied that off. No. Don't panic, Mr. Mainwaring. Don't panic, Mr. Mainwaring. Right, see that there? So that hook's in there. Ta-da. And now you've got a veritable cable car. Another usage of suspension and force of this kind. But say that there, I've got a hold of that thing there. I'm over here, right in the far corner, and I'm sitting here, and I weigh X. How much force do I need to get me, using that chair that's got, maybe those wheels can drive, but you'll get a burst from, some of the power can come from there, and once you're moving, the rest of the power can come from, you might just need a bit of a burst and roll out, coast the rest of the way. Why? Well, because it's interesting to introduce some of these engineering concepts. Because I didn't do it, so if that only interests me, then no one replies, and that's just my own private fucking Golden Gate Bridge, isn't it? So the engineering part, the project management bit, the technical drawing part, we're doing. The studio here, hopefully in time, will be set up to accommodate design teams to work in here collaboratively, and then they put their projects up here in the storage, so we can run more than one team or more than one project out of this office in accordance with that old RAG, Prince 2 and Agile Scrum, until something better comes along. You'll at least understand principles of project management from a Prince 2 perspective, and Agile Scrum's not too shabby either in a lot of places. So we're getting organised. Tension and straps and suspension bridges and shit like that are in vogue, and for practical reasons, because the environment dictates it. Here's a design now. I covered this off in a previous video uploaded to YouTube. So that net there might be 4 nets stitched together, and in each corner there are eyelets there in the corners, and then some rope attached. Okay, and that rope goes down through pulleys, right, as well. So there's a pulley system, and you might get away with one winch, which I thought that Makita drill, and then I sent some batteries. So the idea is to make this thing portable, so it can be stored in the garage. You charge up your electric drill, the Makita drill, which has got enough power to tension the net. The ladders, right, those ladders are in sort of L shape. I'll draw that on the board, I think. Configuration. So L-shaped configuration of the ladder. In fact, I won't draw it. It's one right. Shit. Down here somewhere. Not quite yet. Anyway, it's one of those configurations. And you've got the first leg's bent 90 and the rest is straight. And then that goes up. Whoops. That goes up as high as it goes. 4.7 metres is the total. The first leg will be a third of that, so whatever. you get 3 metres high, and then that thing that goes across the bottom, you have to anchor that with Dynabolts, right, that I thought I sent you. You have to anchor that to the concrete, or you can put it into the ground, or you can make your own little concrete block and bury it, okay, in the dirt, just below, a centimetre below the surface, so no one can sort of trip on it. And then all you need then, okay, is a couple of, well, you can figure that part out. But all they need to do is to take these things here, right, feed through this Dynabolt that's anchored into a block of concrete, right? So you don't have anything poking out of the ground when you take all this down. That's the other thing. Now, the skateboards go underneath the ladders. They're about $10 each. Like these things here. Okay, they go underneath the ladder so that it can be moved quickly. A nice to have that's not depicted here would be a pole that goes all the way across. You've got a ladder there, and you fold that up a certain way, and you fold that up a certain way. Take it off the blocks, disconnect it all, and then it's on a skateboard, and then you've got this thing here on a post, a pole, and you roll that up in one long roll, move those in, pick that up, move them in, doof doof, and now all of that's on a skateboard, and it's on wheels, and you roll it into the garage. Happy days. And in front of that, that's where you put the basketball hoop, right? And the idea is it doesn't go, if you miss your shot, it's a backup net for your basketball hoop, so if you miss your shot, the ball doesn't roll out and far away down a bloody hill or into the ocean or whatever. You know, you've got a backup for it, and then you can lower it, and it's badminton or tennis or whatever, volleyball, whatever you like.